finish him. Kill the guy now. You have to come.
What? What is this?
Good day, sir.
You are watching Jakepan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough like you've been fighting kung fu in your dream. That's the reason why you have F's in your courses like especially made for you.
I have it last semester.
We by pounds on you. Very stupid. We are changing that section to ACTV right now. And oh God, the baby to have been first born. Stupid boy.
Good day to you, everyone. You're welcome to another series in the lecture of SURDS for MTH 105, Elementary Mathematics for Biological Sciences 1. And in this lecture, we'll be continuing from where we stopped in the last class. We looked at SURDS and we're able to check equality of SURDS, and we talked about finding the positive square roots of SURDS. And in this class, we'll be doing examples. We'll look at a recap of what we did in the previous classes. And for the first year, we would be looking at the first question we'll be having here is for us to simplify 1 over the square root of 5 minus square root of 3 all squared. And the second one will be square root of x plus 1 over square root of x all squared. In this class, we would be solving, simplifying this given expression. So as we just go about this, we will apply all the rules that we've learned concerning SURDS. And so can we please just follow as we go on with this. Now in this first example, we have 1 square root of 5 minus square root of 3 all squared. Now if we remember from the algebra of SURDS that we considered, we had that the square root of m minus the square root of n all squared would actually give us m plus n minus 2 square root of mn. Now if we remember this, we'll just adapt this to what we are doing here. So from there, it implies that we would be having our equation, our expression to give us 1 all over square root of 5 minus square root of 3 all squared to become 1 over m. Now it means that from this case here, comparing this, our square root of m will be the same thing as square root of 5, and square root of n will be square root of 3. So this implies that m equals 5 and our m equals 3. So once we know that, we can adapt that to this. So this gives us 5 plus 3 minus 2 square root of m, which is our 5, multiplied by 3. This is multiplied by 3. So this would give us 1 over 8 minus 2 square root of 15. We would have this square root of 15. Now the next thing we need to do is for us to apply our rationalization. We rationalize this by using the conjugates that we've learned. So from here, writing out our conjugates. So the conjugates of 8 minus 2 root 15 would actually be 8 plus 2 root 15. So what we'll do with this is we multiply the denominator and the numerator with 8 plus 2 root 15. So this actually gives us 1 over 8 2 root 15 equals 1 over 8 minus 2 root 15 multiplied by 8 minus 2 root 15 over 8, beg your pardon, plus 2 root 15. Now we would observe that by our division, this would actually give us 1. So it doesn't change the weight of this 1 over 8 minus 2 root 15. So we can actually continue, and if we do that, this would actually give us 8 plus 2 root 15 over, now this would use also the algebra that we would have, would use our algebra, and this will give us 8 multiplied by 8 will give us 64. Then we would have 8 multiplied by that will give us plus 16 root 15. Then this would give us minus 16 root 15. Then we would have minus 4 multiplied by 15. Now this all over. So from this here, we would have to simplify this. Now this is 16 root 15 and minus 16 root 15. So this gives us 0. This would cancel out to give us 0. So we have 8 plus 2 root 15 over 64 minus, now 4 multiplied by 15 will give us 60. So this gives us 8 plus 2 root 15 over, this would give us 4. And we can easily write our answer as 8 over 4 plus 2 root 15 over 4. And this will give us 2 plus root 15 all over 2. Now this gives us the simpler form of this expression that we have as the first case. So we can now move on to example 2. We can move on to example 2. So in our example 2, we would have the square root of x plus 1 all over square root of x all squared. Now, from our concept, the rules of SURDS, we know that the square root of 1 is 1. The square root of 1 is 1. So from that concept, we would have this as square root of 1, and this will give us from the second law of in SURDS, we would have this to be square root of 1 all over x. So this gives us square root of x plus square root 1 all over x all squared. So once we have this, we can apply the algebra, which gives us square root of m plus square root of n all squared to give us m plus n plus 2 square root mn. Now if we compare this with this, it implies here that we would have our square root of m to be equals to square root of x, and it implies m equals x. And also our square root of n is equals to square root of 1 all over x. And this means that n is equals to 1 all over x. So once we know that, we can easily just adapt this in the case. So it means we would have our m to be x plus 1 all over x plus 2 square root, our m is x multiplied by 1 all over x. Now once we have this, we can easily simplify. This would cancel out, x would cancel out x to give us 1. 1 times 1 will give us 1. So here, if we simplify this expression here, we would have 2, beg your pardon, we would have x, and this would actually give us x squared plus 1. We would have x squared plus 1 plus 2 root 1. And so this gives us x squared plus 1 all over x plus 2. And we can easily simplify this further, and we would have 2. Then we would have x squared plus 1, and then we would have plus 4. So we would have here, what we would have here would just give us x squared plus 5 all over 2. Now this is what we have as our answer. We would have this actually as our answer, x squared plus 5 divided by 2. So we could easily write x squared all over 2 plus 5 all over 2. Simplifying gives us that as our answer. So we'll move to the third example that we'll be considering. In this case here, we would consider our third example. And in this third example, we will be determining the positive square root. We'll determine the positive square root of, we have to determine the positive square root of 16, 19, 6, 2. Now, if we are to determine the positive square root, we would assume that we have m plus root n all squared equals 16 plus 6 root 2. So what we'll do here is, for us to do this, then it means that we would expand this, and comparing it with what we have here means that we would have m plus n plus 2 root m n is equals to 19 plus 6 root 2. So comparing this equation together will give us m plus n equals 19, and 2 root m n would give us 6 root 2. Now, if we try to simplify such that we factorize 2 from this, will give us 2 multiplied by 3 root 2. And we can apply the third rule of SURDS to 3 root 2. And this would actually give us 2 multiplied by 9 times 2. And this will give us 2 root 18. So it implies that we have, from this case, it implies that mn is equals to 18. So we will call this our equation 1. This is our equation 1, and this is going to be our equation 2. Now, we've gotten 2 equations that we need to solve. We'll solve concurrently. So we'll solve them simultaneously. Solving this simultaneously means that from equation 1, we would have our m to be equals to 19 minus n. If we have 19 minus n, then we can substitute in equation 2. So we substitute the value of m in equation 2. So it means that equation 2 would then imply that we would have 19 minus n in bracket n is equals to 18. And so this implies that we would have 19n minus n squared is equals to 18. So we can rewrite this as n squared minus 19n plus 18 equals 0. Now, this gives us a quadratic equation. We would solve this quadratic equation using either factorization method, or we use the general formula, or we could as well use any other methods that are listed for solving quadratic equation. Now, here we'll be using factorization method. And for us to adapt the factorization method, we note that we pick the first term, we multiply it by the last term. So this will give us 18n squared. So we look for the factor of 18n squared such that when you multiply it together, it gives you 18n squared, and when you add it together, it gives you minus 19n. So we have minus 19n. And this easiest one that we would have of all those factors is minus 18n minus n. If we multiply minus 18n with minus n, we would have plus 18n squared. And when we add minus n with minus 18n, we get minus 19n. So we could easily from here substitute this in place of the minus 19n. So this implies that we have n squared minus 18n minus n plus 18 equals 0. Now, once we have this, we can now collate terms and get our factors from this. Now, we would get our factors from this. So we put them together, and putting them together, we factorize n there. So n will left to 1n minus 18. Then here we would factorize minus 1. Then we would have n minus 18. This gives us 0. Once we've done this, then we can factorize because this is common. So we have n minus 1. N minus 18 equals 0. So this implies that we would have n is equals to 1 or n is equals to 18. So we can label this as n1 and n2 since we have two solutions. We have two solutions for this quadratic equation. Now, coming back, we'll note that from equation 1, we have that m plus n equals 19, which implies that our m equals 19 minus n. So this shows that for our n1, we will substitute the value of n1, and this would actually give us 19 minus 1 to produce 18. And the second case would give us m2, which is 19 minus n2, and this is 19 minus 18, and this gives us 1. So it means that when our n is equals to 1, m equals 18, and when our n is equals to 18, our m is 1. These are the two results that we have gotten. The two results that will produce those two square roots for us. So we now try to get which one is the positive and which one is the negative. We should not forget that we've assumed that the square root of m plus the square root of n, this is actually the square root of 19 plus 6 root 2. So when we pick the first case, this would actually give us square root of 1 plus square root of 18 plus square root of 1. And from this, we would have, this is 9 times 2. 9 times 2, so we would have 9 times 2 plus square root of 1. And we can easily write this as 3 root 2 plus 1. And looking at this is 3 root 2 plus 1. So this one is actually going to give us a positive, it's going to give us a positive square root. Now we try the second one as well. So here we would be having square root of 1 plus square root of 18. And so we would have the same as 1 plus 3 root 2. Now looking at this also, this actually gives us a positive square root. And if we were to say, we would observe that this and this actually produced the same square root for us. So the square root of this would, 16 plus 2 root 2 gives us 2 positive square roots, which are actually the same. So when we try to multiply them, that is what, when you multiply this with itself, it gives us 19 plus 6 root 2. We've been able to look at that particular problem. So from here, it is assumed that for us, going through all this, whenever we come across issues of SURDS in computation, we should be able to manipulate our ways to make use of SURDS to solve computations. So in this particular class, we would be drawing a curtain on SURDS so as to continue other topics that are in the course content. So for this, we'll be expecting that the notes with us, we should please try as much as possible to lay our hands on those exercises and work on them as much as possible that we can do. So we'll be drawing a curtain to this class. Thank you very much for the lecture. See you next class.
Finish him. Kill the guy now. Round the corner.
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can do. You can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have it last semester.
We by pounds on you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.